So in previous video, I told you the difference between supervised learning and unsupervised learning. I will link it into I button, or I will link that video into end card. But yeah, in previous video, I gave you the difference between supervised learning and unsupervised learning. What is clustering? How many types of clusterings are there? And what type of algorithms are there in different types of clustering. So in that we discussed that clustering is divided into two parts, which is hierarchical clustering and then there is partitional clustering. And hierarchical clustering has two parts, which is divisive and agglomerative, and partitional has k-means and fuzzy c-mean. So today we are going to code our agglomerative clustering, which is a form of hierarchical clustering, and I will use zoo.csv dataset, which I have in my system. So I will code agglomerative clustering, and I will tell you about every library which I am using, how I am doing things. So let's start then. So we will import our three basic libraries, which is NumPy and pandas and matplotlib. What is the function of these three libraries? So NumPy, in very basic sense, you can understand it as a math library which is used for performing maths on our data set, like working with matrix and everything. Pandas, what is pandas? Pandas is basically a library which help us to make data frames out of our data. It is used for working with our data set, because when we get our data in very raw form, there are things which we don't want our data to have. We do filtering, and we can explore our data. We can perform operations on our data with pandas. And what is matplotlib? Matplotlib is actually a library which help us to plot a graph out of our data set to visualize our data. So these three libraries we will use in starting our agglomerative code. And let's import these three libraries and we will continue from there. So I will say import numpy as np. Why I'm writing as np? So I want numpy to be represented as np, because writing numpy every time is very tedious. Like if I have to work with some data and I have to write numpy every time, that will be very tedious. So I'm saying that numpy is as np. Whenever I will say np, you should understand that I'm talking about numpy. Then we will go and import pandas as a pd and import as plt. So these are the three basic libraries which we will going to use. And we can do one more thing, that we can say percentile matplotlib in a line. What percentage matplotlib inline does, when we plot our data, if we don't write this thing, it will open a new tab for visualization. But if you include this, it will give you that data visualization here only in this where we are working. So this is why we are saying that percentage matplotlib inline. I want data in this window only. So let's run our code and let's see. It will take a few seconds or minute to import the libraries, and then we will go and import our data set, which is zoo.csv, and we will see whether what are we working with in our data set and how we can get an information about our data set by pandas. We will do that. Okay, now we imported our library successfully, because we don't have our IDE is not showing any error. So let's import our data. Let's say this is, I'm making a variable which is known as data pd for pandas.csv. Why we are using csv, read csv, sorry. why we are using CSV. CSV is basically comma separated files. It is used for comma separated file, and we are using that pandas.read CSV that read this CSV file, which I'm going to import, and that is zoo.csv. So it will take the CSV file and read it, and let's say we want an information from our CSV file, so we will say data.info, and this will give us information about our file which we are working. So as you can see, we have columns, animal name, hair, feather, egg, milk, airborne, aquatic, predator, toothed, backbone, venomous, fangs, breaths, legs, tails, and all kind of data is there. And int64 represent that this is an integer value. See, all of this is like integer value, and this is an object. Animal name is an object, and yeah, this is the data which we are working with. So, and there is total 101 entities which have 18 columns. We have our 18 columns in our data sets, including 0 to 17 is actually 18 columns, 17 int64 data types, and 1 object data type. So we got this information about our data type. Let's go and make a variable label and say data and class type. So if we do that, let's see what happens. It will take this data class type column, and it will store it into labels. And what you can see here is that these value doesn't have any significant direct dependence on our data set. I'm using dependent and independent variable, which is not true with the supervised learning, but in a sense which I'm saying that let's take something out of our data set which we can use to protect our data set. So I'm using class type column for that. So now let's see how many unique values are there in our data set. So I will say print np again, numpy library dot unique np dot unique labels. Wait a second. Label dot values. So this will this should give us unique values which are present in our label, which is class type, which is this unique value in this. So I think it will be label underscore or dot. Let's do it first. So it is giving us 1 2 3 4 5 6 7 for so these are unique values which are in our this class type, and yeah, it is a data array of a number 1 2 3 4 5 6 7. Let's go ahead and plot a graph. And if you're thinking what I'm looking into in this is, that is I'm taking help of my note which I made in years, so that I give you correct information and you get correct information. So let's say figure. If you want to these are a variable name which I'm writing. You can have your own variable name, whatever you want. So figures axis plt for matplotlib dot subplots, and theoretically what it should do, it should create a subplot. And what kind of subplot? Let's say we are going with labels, I guess, labels dot value value count. It will give us the count of our value label, how many values are there in label. Then it will plot that thing to ax, which is the axis, or let we have make variable of this, and we want the graph type to be bar chart. So let's go and say bar, and this should give us a like bar graph. And what we can do further is that we can say that features. See, in like supervised learning we have labels, but in unsupervised learning we go for features. Like we categorize, we work with our data with some sort of features. Like different data have different kind of features. Let's say there are aquatic type animal which we want, that is a feature, like of animal who are aquatic in type, who are predator, who have fins, who have legs. So we can use that, we can say features, and that is a variable, and I will say it will store data dot values. So what is the meaning of this? When we write a semicolon, it will when we write this, let me explain this to you. So I am making a data frame, and I will go ahead and let me write this like whole thing. Okay, so what does this mean? So this represent row and this represent column, and I'm saying that I want to store this value in our feature. Now what is this value? When we write a semicolon, it actually says that take all the rows. Like semicolon means take all the rows, as in like this is row over, this is like horizontally these are known as row, vertically is column. Okay, so I'm saying that take all these rows, and we want column 1, and this is -1, which is like last column from first. We want that, so we want all rows and we want first to last column. Okay, and store it into feature. See, we want animal name and we want our class type as a column. So we will take features, and let's check shape of our features. Like I think I should separate this code into 2 cells, but let's run that. So yeah, features are the non-defined feature. I think this should work. Okay, there is a spelling mistake, my bad, because as you can see I like spelled this wrong, and then that's why I'm not getting it, because I like FEATURAS. Now it should give us what we want. Yes. So we have our figure which represents like axis, and we like what is axis again? Axis we have defined somewhere. Let's say label.value count. It is actually representing label.value count. What is label? Label is class type. Okay, and how many values are there? See, 1 2 3 4 5 6 7, and as you can see that there are 1 2 3 4 5 6 7 unique values. So there is this 1 2 3 4 5 6 7, and they have a value count like one have a value count of 40, 2 have a value count of 20, 4 have a value count of around 15, 7 have around between 10 to 15, 6 have around 10 I guess, 5 is like 3 have a value count of 5, and 5 is a value count between 0 to 5. So this has given us the data and the unique value which we have in our class type, and the number of values which we have. And we have said that we want it into bar graph that we are seeing here. And then we said that features, number of features, how many features we have, and we are taking all the rows and this column 1 to -1, and that is giving us this. Say we have 101 rows and we are having 16 columns. How 16? Like we are like excluding -1, and we are starting from -1 and we are going from, like we are starting from 1 and we are going to -1. So we are excluding this and we are excluding this. So these are the features we are taking. So on total we have 16 features, as you can see. So we worked with our data, we saw what kind of data we have, we got the information of our data, we plotted unique values from our data, we got the shape of our features, how many features are there, how many unique values are there. In next video we will go ahead and actually use our agglomerative clustering algorithm, and we will do that by scikit-learn library, sklearn library, which will provide us with the feature of agglomerative clustering which we can use to work with our data. So see you in the next video, and till then be happy, spread peace, and peace.